So I'm Silvia. Some people that know me online know me as Hero. I work at the Tor project, and I've got my PhD not too far away from here, actually 2-3 minutes walking at UPC in Barcelona. I research in privacy and security of information. So today I'm going to talk about Tor and how you can use it, especially. We're going to talk about how Tor provides privacy, about how it provides anonymity, about how you can use the Tor browser, and then we're going to talk about onion services, which is something that started as a toy project, but it's actually a very cool feature that lets you use the Tor network. And the last point is how you can use onion services for your project, personal project, or your web applications. So what is Tor, and what it can do for you, especially? Tor is a privacy tool, which is the biggest, wider definition that I can give. But it's also free software. It's a community of people that develop over Tor, research. There are relay operators that run the Tor nodes that you can use when you connect through the Tor network, and there are volunteers that do lots of different things. Tor is an open network, and it's also no-profit. So there are about 2 million daily users using the Tor network. And these people use the network for a bunch of different things that sometimes we don't even know. But the example that we always give is that the biggest services on the Tor network is actually Facebook, and it's used by people that couldn't reach Facebook otherwise. There are about 6,000 relays and 2,000 bridges. Relays are actually node in the network, and bridges are a node that allows you to get into the network in case there is censorship in your country or things like this. This is actually interesting. The lower graph is the bandwidth used, and the upper graph is the bandwidth advertised. So this shows the capacity of the network. It's about 200 gigabit per second bandwidth advertised. A little bit more, actually. So we said Tor provides privacy for its users, provides anonymity. We can also say, and it's always the same thing, it also provides communication security. And if you want to look at it in a more technical way, it provides a traffic analysis-resistant communication network. That's the long definition, in a way. But for many people that use Tor, especially in difficult parts of the world, it's just reachability, or it's the possibility to read the news. So how does Tor provides privacy and anonymity? So we talk about privacy by design. Tor provides privacy by distributing trust. When you use a VPN, you have some privacy properties, but you have to trust the VPN provider. You have to trust that the people you pay or you ask to provide the services will not sell or give access to your metadata or even your actual communication. With Tor, you don't have to do this. You just have to use the protocol. So how does it work exactly? There is Alice. In every cryptographic talk, there is Alice and Bob, and they want to talk to each other. In this case, Alice can be some user that has opened the Tor browser, and he wants to access a website, like the BBC, the CNN, or any website. So Alice opened the browser has some software in it, and receives a list of nodes that she can connect to in order to reach Bob. Given these nodes, Alice builds a circuit over the Tor network and is able to talk to Bob. The green connections are encrypted and are within the Tor network. The last up is actually unencrypted. So although someone looking at the traffic that is reaching Bob wouldn't know that this communication is coming from Alice, they will still be able to read what the communication is about if they're not using like a safe protocol, for example, HTTPS. So, for example, passwords and so on would be in the clear in that case. So that's why it's important to use still encryption or encrypted protocols and so on. Yes. And then if at a later time, Alice wants to visit another website that is called Jane, there will be another secret that is built so that it wouldn't be possible to link the two activities among the website. And this is particularly important for tracking across different websites. So the property that the Tor network provides is that Alice can, in a way, communicate safely, meaning that someone that is observing the traffic doesn't know where Alice is going, and someone that is observing the traffic from Bob doesn't know who is coming from this traffic. So, and also, the other thing that is actually important is Alice doesn't need to trust any service provider or network provider in order to think that the communication is happening safely, because it's encrypted. And it's not just encrypted. The communication is anonymous, and anonymity is more than encryption. There are a lot of things that encryption just doesn't do. I made the VPN example, that you need in a VPN or in a proxy, you have one cable coming in or one stream of traffic, and there is a stream of traffic coming out, and someone observing the traffic will be able to understand, for example, who is talking to, who are the people that are talking together, and this is actually called metadata. And by serving metadata, you will be able to, for example, understand the friends of a person or the people that are connected somehow. And the Tor network protects against this, because there is not one single point of failure. Everything is distributed on the network. The application layer of the Tor network is the Tor Browser. So the Tor Browser basically is a Firefox that is modified, a package with some software that starts Tor and provides some privacy and security properties. This software is exactly Tor, Tor Launcher, Tor Button, but also NoScript and HTTPS everywhere. So NoScript is actually an extension that blocks some kind of JavaScript in certain situations. So why do we have a browser? First, to ensure the safe use of Tor, and also because we believe that people should be able to surf the web without being linked across different website visits. And that protects against traffic analysis, for example, or even tracking on websites. So now we talk about onion services. Onion services, basically, let's go back 1 second, are a way to provide bidirectional anonymity. What does this mean? It means that I can connect to a website, or I can talk to someone, and they don't know that it's me that is talking to them, while at the same time, I protect also the server location. Next generation onion services were launched last year, and they had some other features that were introduced. For example, one of these features was better cryptography. We use SHA-3 now. The service address is now the public key of the service directly. And it's one very good property is that you can create subkeys from the main key so that you can share different keys with for different purposes with different people, for example, so that the main key can stay hidden and ensure that the identity of the service remains secret in a way. There's also rendezvous single onion services. I'm going to explain a little bit this later, but the idea is that when you use an onion services, you connect to a Tor network, and to this Tor network, either the server and the user connected to the server, they have 3 ops each. So it makes 3 hops one side, the rendezvous node, and 3 hops. So this sometimes, it's a lot of hops. And some people say, for example, that there are situations in which the server doesn't want to protect their identity or location. Like, for example, if you're connected to the BBC or Debian.org. So you just, in this case, the server connects directly to the node, and the user has a Tor network. Using the Tor network has 3 hops to this node. We'll see this a little bit later. And then there are some other features, for example, that were added to avoid some attacks that we're doing to discover who they are on service to and who was talking to them. And also some other things about, for example, the description ID. There is some information that is shared with the network when the service connects. So let's say how actually an onion service works. So let's say that Bob this time is a web page again, and there is Alice. Alice is using the Tor browser. So Bob wants to say, I'm a new service on the onion network. So what it does is it picks 3 nodes on the network. These are 3 relays, and just build a circuit. Building these circuits, it puts everything into files, delete the descriptor, and it sends it to the directory. The directory is called hidden service directory, because in the past, onion services were called hidden services, and then the name was changed for press reason, actually. So the directory is like a database of the services, and later on, when Alice wants to connect to Bob and knows that the onion service exists, Alice can fetch the descriptor from the directory and learn how to reach Bob, because she will know that there are 3 nodes in the network that allows her to connect to Bob. So also what Alice does, it picks another node that is called rendezvous point. So using the first node in the circuit, Alice tells to Bob, hey, Bob, meet me at the rendezvous point. So what actually happened is that the previous circuit that Bob created is destroyed, it's basically discarded, and both Alice and Bob connect to the rendezvous point using a Tor circuit, so it's 3 hops, and they share a secret to enable end-to-end encryption. And they just use the Tor circuit like normal. So there are interesting properties of the onion services. Sorry. The first property is that this communication happens entirely on the Tor network. It doesn't go out. And so you don't have to worry about HTTPS or other protocols, for example, because it stays within Tor. What this means is that if you want to connect to Bob, in theory, and Bob was a service that you're using, you wouldn't need to expose this service to the outside internet. You could just expose it on the Tor network. So this limits the attack surface in a way. Let's say that Bob was just providing SSH access or something else. He wouldn't need to expose anything outside of the Tor network. It just could be inside. And this is actually interesting, for example, for some situation in which you would like to protect your infrastructure, or you would like to share a service privately with other people. And we will see how this works. OK. So this is the idea, actually. What if you could use the Tor network within other applications through onion services? And this is the thing that I would like that you take out of this talk. I would like to see that it's possible, that it's not complicated, and that it's actually useful, and you could experiment with this. So there is this idea about onion microservices, maybe. I've been thinking about a web architecture, for example. You have a web server, you have an app server, and your user communication comes to the web server. And the web server, for example, is exposed but you don't need to expose the app server. So of course you can use NAT, for example, but what if it's not on the same network and so on? You can connect just through Onion services. And you wouldn't need to worry about certain kind of attacks, for example. You would need to worry about others, but not all of them. So I made an example to show that it's not that complicated to expose an Onion services on the internet. And this is just a minimum configuration that you could do by setting up a Docker container. So I used Docker Compose in this case, and I just set up the SSH server and nothing more. Basically, if you see the thing that I have installed, it just open SSH server, Tor, and Vim to edit some files. And that's everything you need to do to expose an Onion service, basically. So what we provide is a configuration file that you can edit. And the configuration file may be a little bit complicated at the beginning because it's used for everything. It's used if you have to run a relay, if you have to run a bridge, or if you're just using Tor. But in this case, if you need to just expose a service, you would have to say the indent service directory where Tor saves a few information, for example, like the key and the onion address, and just says the port and the port that is exposed, and that's it. It's 2 lines that you would need to edit in this file. And then once Tor is started, and in this case, for example, the idea was that there is a user called Tor, and an Onion SSH servers folder is created in the home or anywhere you wanted, and that's it. And if you wanted to expose more services, you just add it to the configuration files with the folder, the port, and everything. So in this case, the idea is that you just could start a Docker container from your machine, and then when you would SSH, you would SSH to the onion address by using Tor socks. This is another thing. Tor socks is a wrapper that is provided when you download or you install Tor. And basically what it does is routing your traffic through socks 5 and using Tor. So basically, you could run a curl, you could run any other protocol through Tor socks, and it's using the Tor network. And in the past, we used to call Tor socks Torify because it's a way to make application work on Tor. And we actually provide a node too. It's a little bit of a working process because it contains a lot of information about when and how you should Torify an application in order to know that when you expose a service through the Tor network, you have to make sure that it's also not leaking other information. But it's actually, for example, a cool feature you can use just to know, hey, I want to try this API. Can I reach it through the Tor network? Does it work? Does it not work? What it does. Or is from the other way around, it's a way that you can expose a service only on the Tor network. So this is another example, and it's a few lines of code in Python that allows you to use the socks 5 proxy that is provided by Tor, and it's what Tor socks use. So I didn't install anything specifically. I think a request comes with Python. If not, it might not come with Python, but you might have to fetch request, which is a library. And the thing is that you need a library that supports communication over socks 5 or socks in general. Some programming languages, unfortunately, do not support that. I tried to have also a Ruby example, but I heard that in Ruby, support for socks 5 is not that good, which is a shame because I really love Ruby. And then all you have to do is do a get and tell to use the proxies. And in this case, even the DNS request go through Tor. So you wouldn't have the DNS request go outside of Tor. Everything would be within Tor, and you would be able to fetch, for example, an onion address. Or in this case, the onion address is the address for the archive torproject.org. So the other idea is that what if you can use Tor for peer-to-peer application? And there are lots of examples that you could do. SSH was one example. You run a SSH server, and you address it only through Tor. The attack surface is smaller. You make advantage of You make advantage of the censorship-resistant property of it. But there is also another example is using secure drop, for example. I use Onion services. But also there is this small app, it's called Onion Share, and it's used to share web files. You basically, when you use it, you select a folder. The folder is zipped. The app starts an Onion services, and it also starts a Flask web server, and provides you with an Onion address that you can share with people as long as the app is running on your computer. So people download the files. You get actually a counter of how many people have downloaded the file that you shared, so that in case someone learned your Onion services, you wouldn't be able, you will know that lots of people have downloaded the files. And that's it. You close the app, and it's basically done. It's shared safely, and it's shared peer-to-peer, because it doesn't even go on the network. It's shared over the Tor network, and that's it. So the other idea was like, what if we use this property of Onion services, and we start building applications that are peer-to-peer, for example, or we start using Onion services because we want to share the prototype of application that I've been working on my computer, and I just want to share it with a coworker, for example. Or just say, OK, I want to work on something quickly, and I want to provide an Onion link. People access the Onion link while they need it, and then I shut it down, and that's it. So the idea is, what if we start a container, and the container has some image that I want to share because, for example, I have a web server, or I have an application server, and so on. And I'll start wrapping a simple example. I mean, this is probably minimalistic. There are other things that go into it. But the idea is that you don't need a lot of line of codes to start experimenting with the Tor network and start building secure application. It's actually, there is, for example, in this case, I'm using Docker because it was convenient. And there is a Docker library for Python. So you install the library, you import it, and then you just say, hey, connect to the Docker socks, and that's it. And then what you do is you provide a Docker file, and you start a container. And then on that container, you decide which services you want to use. And let me put the file up. Let's see. Oh. I'm lost with that. OK, this way. No, I didn't want to do this. OK. But basically, on the Docker file, I'll try to narrate it. What happens is you just tell the container what you need installed. So you need the Nginx. You can use the Nginx image that is provided by Docker. And you just add that you want Tor installed. Once you add Tor installed, you just provide the Tor.rc files with the service that you want exposed. In this case, the Nginx or whatever. And you just launch Nginx. And you make sure that Tor is launched as well. That's it. And so basically, no, this way, OK. So once you have something and you have an Onion address, you just share it through the Tor browser like this. And if it was not just an Nginx server, it could be an application that you wanted to share peer-to-peer. And if you have, or if you have issues with censorship, or if you live in a country where you don't want to, no, this way, okay, perfect. You don't want people to know that you're sharing something online, or you cannot afford hosting. This runs directly from your computer, and it's a quick way to build basically an application and share it with whoever you want. So this is basically the end of my talk. I don't know if you would like to send some more questions through Twitter or...
Tor is traffic analysis resistant. You said that you don't usually know what people are using it for. You also said it is commonly used for Facebook access. So how, when, and why is some traffic monitored?
So we know that information because we have some metrics, and that information is provided by Facebook also.
Ah, okay.
So they know how many access they have through Tor, for example. And regarding the first question, basically, you don't have to trust the network. So that's the first thing, because you trust the protocol. The protocol is open source. There is a design document, and if you want to contribute to the code or to the design document, you can look at it. And another thing is also that you know the people that are working on Tor. So basically, many Tor developers, many people that work on Tor go around, they give talks, they say, hey, I do this, so that you are publicly identifiable. And people know that actually there is not some hidden service behind it. And then another thing is, yes, if the communication is not encrypted, there could be analysis on the exit node. Or also there could be analysis on the exit nodes of the traffic that is coming from. But the exit node only knows that there is a middle node that is sending traffic. It doesn't know the person that initiated the communication. So the Tor network provides this property that I use the Tor network, and when I visit a website, the website doesn't know where this traffic is coming from. But people also that are observing my traffic, they don't know basically where I'm going, which is which websites I'm actually, I do want to visit and I'm visiting.
Okay. Okay, I will ask more questions later because there's so many. I apologize for the people that I won't cite here. So there are two questions about reliability from David on Twitter. Did you ever detect any attack on Tor network aiming to breach its security? And the other one is, if eventually onion services start to be used as a way to protect services from attacks, wouldn't that heavily increase traffic and so penalize traffic of the users that actually need Tor to access information?
Okay. Can you repeat the first question?
It's basically about the resilience to attacks.
Yes. And so the first one?
Did you ever detect any attack?
So one of the most common attacks on Tor is using building a relay. Anyone can build a relay. And for properties of the networks, when relays spend more time on the network, they get promoted in a way. For example, a relay can become hidden service directory. And so what people... There is some mitigation to this, in which we run some analysis on the network to find bad relays. And actually, the algorithm that does this is the only thing that is secret, because we don't want people to have an advantage on this. But the thing is that when a relay is in the directory, there are some attacks they can do to find out who is the hidden services and who is trying to talk to the hidden services, but just observing the traffic. And there are actually a few classes of attacks. One is timing attacks, trying to understand if this person is making a connection and if this hidden service is replying, try to match things, for example. It's a little bit more complicated, but it goes around these lines. And the other question is about resistance.
If eventually onion services start to be used as a way to protect services from attacks?
So
question about
there is
traffic?
one important property of the Tor network. There is the diversity. And this means diversity of traffic, of relays. It means small relays, big relays, relays that are on the same network, relays that are different network. I'm going to explain this because it's a little bit maybe difficult to understand. But it goes with the idea of population or people that are similar. If all the people that like sports only use the Tor network, people will know that it's only people that like sports and the traffic is about sports. If there are people that like lots of different things like sports, music, or business, whatever, that would be more difficult to identify single people. So the diversity of the traffic use, so let's say web surfing, protecting infrastructure or other uses, chatting and so on, gives the possibility to mitigate, for example, traffic analysis. But also the difference in relays, meaning that if all the relays that people run are on the same network, for example, DigitalOcean, then DigitalOcean will have a lot of Tor traffic that they can analyze, or Amazon, for example, or other things. So this property of diversity of people using Tor for different things is actually a good thing for Tor.
Yes, but I think that the question was more about the resiliency to heavy traffic. Like, wouldn't it get very slow so that I need...
Ideally, we would be able to add more relays and be able to support more traffic.
Okay.
If we have people that use it more. For example, one thing that is, I think the beta or alpha version of Brave, when you run a private tab, you can run it within Tor, so that it's a little bit more private than just an incognito tab, because it's not only blocks JavaScript, it not only blocks tracking, it also sends this traffic in this browser tab through the Tor network.
Okay.
So
I think that I have some time for a last question. Peter on Slack asks, are these relay nodes you would route over verified parties and safe to use, or can anyone have or create a relay node?
anyone can create a relay node, even if you have a Raspberry Pi, for example. Okay. It would be just a little bit more flaky in terms of the network bandwidth that you provide. So, for example, you won't get promoted through the network. But the idea is that the network is owned by everybody and nobody at the same time.
Okay. And
I think there was another question about running bridges. So it's the same people that run relays. They can say, I run a bridge. And so when it's basically a choice that you allow people to use your bridge to enter the Tor network.
Okay. Okay. There's plenty more questions on Slack and on Twitter. So
I left time for you.
No, I think we can let you some time to answer them one by one, calmly. Okay?
Okay.
So thanks a lot.
Thank you.